Okay, in this video, I want to show you what is a binomial expansion pattern. Now, binomial expansion pattern can be used to answer this question. And the question is, when we have a binomial a plus b raised to the power of m, where n is a positive integer, like 1, 2, 3, 4, 5, what the result is. Now, there are two cases we already know. One is when n equals positive 1. Because when n equals positive 1, a plus b raised to the positive 1, it is a plus b, right? And the second case is one of the special pattern when n is 2. So a plus b raised to the power of 2. The result is a squared plus 2ab plus b squared, right? And when n is a 3, in my previous video, I showed you how to do this. The method was we rewrite this into a product of a plus b times a plus b times a plus b, and then first we multiply a plus b by a plus b, so we get a squared plus 2ab plus b squared, and then we multiply this by a plus b. Right? Now, this method is good if the n is a small number, but if n is a large number, this method is not very good because you have to do a lot of work. So I want to show you a easy way and an efficient way to find the answer. So first, let's look at what is the relationship between this integer and the number of terms in the result. Now you see, when the integer is 1, we have 2 terms in the result, right? And when the integer is 2, we have 3 terms in the result. And if you remember the answer of my previous video, when the integer is 3, let me show you. When the integer is 3, in the result we have 4 terms. So the relationship is the number of the terms in the polynomial is always 1 greater than this integer. So that's why, see, when n equals 4, we should have 5 terms. Okay. Now, next, how do we know how to write each term, right? How do I know the first term is a, the second term is b, and like here, the first term is a squared, the second term is 2ab, and the third term is b squared. How do I know this? Okay. I'm gonna start with these two cases. We know the result is a plus b, right? And also we know that a we can write as a times 1, and b we can write as 1 times b. Okay, why I'm doing this? And also we know everything raised to the power of 0 equals 1, right? So the first term I rewrite into a times b raised to the power of 0. And the second term I rewrite into a raised to the power of 0 times b. And because a is a raised to the power of 1, and b is b raised to the power of 1. So therefore, we can see actually every term is like a product between a and b. But a and b are raised to different exponent, and the exponent of a in this example, the exponent of a changes from 1 to 0, and the exponent of b changes from 0 to 1, which 1 corresponds to this integer n. And let's look at the second case. We know the result is a squared plus 2ab plus b squared. So if I rewrite this into a product of AB. So the first term is a squared times b to the power of 0. And the second term is a to the power of 1 times b to the power of 1 plus a to the power of 0 times b squared. So we notice one thing. The thing is the exponent of a is going down from this integer to 0, and the exponent of b is going up from 0 to 2 to this integer. So therefore, let's say a plus b raised to the power of 3. First, I know there should be 4 terms because the integer n is 3. And for each term, the exponent of a changes from 3 to 2 to 1 to 0. And the exponent of b changes from 0 to 1 to 2 to 3. Okay. Another way you can remember this is the sum of the exponents is always equal to the n. You see here, 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. 0 plus 3 is 3. Right? Okay. Now we figure out how many terms do we have in the polynomial, right? And also we figure out how to write each term. Now, one more thing we need to figure out. That is how to determine the coefficient, right? Okay, and I will show this in the next video.